Okay, so 5.5, we are going to continue solving quadratic, but all of these solutions should have imaginary roots. So we've seen that before, but remember that you get an imaginary root when you have a negative number under a square root, okay? So you can now use different strategies though, and we're going to mix them all up. So we have seen imaginary roots before, but not with all of the techniques, okay? So if you want, as a reminder, you can use the discriminant if you have an equation in standard form, ax squared plus bx plus c, and it will tell you if you get imaginary roots. Remember, if your discriminant, which is b squared minus 4ac, is negative, okay? Otherwise, you can just solve the equation using the quadratic formula, vertex form strategies. We will be learning completing the square and isolating the x squared, okay? So we're just going to really focus on figuring out which strategy we want to use. And if I use one strategy, there might be options, there might not be. So as a friendly reminder, you do get an imaginary number when you have a negative under the root. Please simplify the roots. I don't really want decimals, so we have exact answers. So we can use the quadratic formula. We will need equals 0 to get all terms to one side. And typically you want to use the quadratic formula or factor, I'll say, if you have 3 terms. So like 2x squared plus 5x plus 3 equals 0. If I had all 3 terms, an x squared, an x to the first, and a number, you either want to factor it or use the quadratic formula, okay? Number 2, complete the square, which we don't know this yet, so I'll take that off the notes and revise this. And then number 3, isolate the squared term. So you take the square root of both sides. This could be with a parenthesis or with just x squared, okay? So let's go ahead and look at example number 1. So if we want to solve, the first thing I notice is that we have this parenthesis here. So if you don't want to multiply that out, which typically you don't because it's more work, then we want to get this root alone as a reminder. So we have seen this strategy before. It was in 5.3. So that means we're going to have to move the 3 and we're going to have to move the 18. So remember, we always do reverse order of operations first. So we are going to add and subtract first. So we will subtract 18 from both sides. So this comes down. 18 minus 18 does cancel. And then negative 18 minus 18 is negative 36. It looks like it's 0, but just make sure you watch your signs. The next thing, that 3 is being multiplied, so to move it, we're going to divide by 3. So x minus 5 plus 5, quantity squared, equals negative 12. And now remember, our parenthesis is alone, so we need to do the inverse operation of squared. So that means we are going to take the square root of both sides because square root and square cancel. So we're just left with the inside, and we don't need any parentheses. Now, when you take a square root, remember it's plus and minus. And anytime you had a negative under the root, remember that made it an I. And I'm going to leave the 12 alone for now. So we want to simplify all square roots. So for square roots, remember we look for doubles. So I want to break down 12 into 4 times 3. And then break down the 4 into 2 times 2. So here's a double. That will go once on the outside. We usually write it in front of the I, and the single will stay inside the root. So we get x plus 5 equals plus or minus 2I root 3. Our last step is we want to get x alone. So we are going to subtract 5 from both sides. And remember, we can't really subtract 5 because this is attached to the I and the root, but we can write them side by side. So negative 5 plus and minus 2I root 3. And this would be our final answer. It's the exact imaginary answer, and we have 2 solutions. Okay. All right, let's try a different strategy. Let's look at example number 2. So on this problem, what you notice is we have an x squared term, but I don't have x to the first anywhere. So since I don't have both powers of x, we still want to use that strategy to get x squared alone. We just don't have a parenthesis this time. So we need to move the 5 and move the 1. We always do adding and subtracting first, so we're going to subtract 1. 5x squared, this is 0, and add these two together, we get negative 65. To get x squared alone, that 5 is being multiplied, so we're going to divide both sides by 5. X squared equals negative 13, and it does go in evenly. So then we need to do the inverse operation of squared. So we're going to take the square root of both sides, so those cancel. We get plus and minus automatically, and the square root of a negative is an I on the outside. The 13 is going to stay. So now, if 13 breaks down and we want to look for doubles, but 13 doesn't break down. So what does that mean? Well, that means that this is our answer. We're done. If you can break down your root, then you would keep going, okay? Just like we did on our first example. It really just depends on the problem. All right, let's look at example number 3. What I notice is I have x squared, I have x to the first, and I have a number. But the x squared and x first, that really indicates I want to either get all terms to one side and factor or use the quadratic formula. This is really just going to depend on your strength. Now, remember, not all equations factor. So what I'm going to write up here is we'll say factor. But I will say it doesn't always work. Not all equations will factor. The quadratic formula always works. Also for factoring, we want the equals 0 as well. So no matter whether we factor or use the quadratic formula, we need to get all terms to one side anyway. And then we can decide which one we want to pick. So that means I want to move this 7 to the left, so we're going to add 7 to both sides. So x squared minus 18x plus 98 equals 0. Now, you could try the AC method for factoring. If you don't like factoring or don't remember factoring or don't want to factor, then you can use the quadratic formula. I'm going to just use the quadratic formula because I think more students will use that than factor. I don't know. It's a choice. I'll tell you at the end if this was factorable or not. So I'm going to put a 1 for A, B is negative 18, and C is 98. So it is a big number. On our quadratic formula, remember it's the opposite of B plus or minus B squared minus 4 times A times C all over 2 times A. So let's substitute the numbers. The opposite of B would be positive 18. B squared, since it's a negative, I'm going to put that in a parenthesis. It does matter. Times A is 1. Times C is 98. Now, I'm going to all divide by 2 times A. Okay? As a refresher, the first step on the quadratic formula to clean it up is to type this into a calculator. All right, so I'm going to go ahead and do that. Make sure you're using your parentheses though. 4 times 1 times 98. So I got negative 68. So I can tell you right now that this equation would not have factored, okay? Sometimes you can tell by looking. This one, without doing a little bit of experimenting, I couldn't tell because 98 is a pretty large number. So I'd have to do a little bit of work on the factors. So I got 18 plus or minus, and I got negative 68 all over 2. Like I said, factoring does not always work. The quadratic formula will always work. So now what you notice is that we have a negative under the root. So I'm going to take the negative out with an I on the outside of the root. Notice it's not by the 18 though. And then we want to break down 68 and look for doubles. So 60 is a pretty large number. Since it's even, I'm going to divide it by 2. You don't have to pick big numbers. And then that gets rid of 68. So 2, and then 34 breaks up into 2 times 17. So here's the double. And so what that means is I'm going to actually put a 2 out with the I. The 17 is going to stay in the root. So let's write that nice. I get 18 plus or minus. Now it's 2I root 17 because 17 was single and it doesn't break down. All over 2. Now, we've seen this before with the quadratic formula. We actually have one step. We want to check all 3 numbers on the outside to see if they reduce. Okay? And reduce means divide by the same number. So all 3 of these actually divide by 2, so you have to. So our final answer is 18 divided by 2, 2 divided by 2. You never change the root though, and then 2 divided by 2. Now, since I just divided by 1, I can leave my answer, or really it's just the numerator. And I don't have to write the 1 in front of the I. So this is probably the cleanest answer, but I would take a few other versions, okay? This one is not done, so we do need to keep going, okay? So that was pretty long. That's a lot of steps and review math. All right, our last problem that I want to show you is this. So what I notice is that I've got a squared term, and if the b's bother you, you can change those to x's. And I have b to the first. So once again, that either means I need everything to equal 0, and I can try factoring, or we can do the quadratic formula. So either way, I want to get everything to one side. I'm a big fan of leaving the b squared term positive. So since it's already a positive 3, I'm going to choose to move 2 terms this time to the other side by doing the opposite. So plus 8 plus 8b. So we do get 0, and then I just write these in the order. So 3b squared, then I write the 8b, and then I write the 8. Okay? So we know that a is 3, b is 8, and c is 8. So my quadratic formula is right here, so I'm just going to go ahead and use that. I don't have to rewrite that. So I take the opposite of b, so negative 8, plus or minus b squared. Since 8 is positive, I don't need parentheses. A is 3, and c is 8. All over 2 times a. So to simplify, we're going to type everything under the root, but not including the root, in the calculator. So I got 8 squared minus 4 times 3 times 8. Oops, I hit minus. Times. I did get a negative number. So if this was a positive number, all that means is that it's not an imaginary solution. I just thought I would show some more negatives since we saw quadratic formula, but none of those were negative roots. So negative 8 plus or minus, and then I got negative 32. 2 times 3 is 6. So 2 things. Since this is a negative under the root, we can take it out with an I, and then I need to break down 32. So let's do that over here. I'll just do it down here. So 32, I'll do it up, is 8 times 4, and then 8 is 4 times 2, and 4 is, you know what? Since I have a 4, I'm just going to leave the 4. So here a 4 is a double. So even though it does break down, if you notice that it's a double, we can take it out. It saves you some work. This 2, though, don't lose it, that's single. So I'm going to write that nicer. So x equals -8 plus or minus 4i root 2 all over 6. Now we could be done. So once again, we need to check the 3 numbers on the outside to see if they reduce. Well, they all divide by 2. So we have to. So x equals, if I divide by 2, divide by 2, the root always stays the same, and divide by 2. So this time I have a denominator, so we're going to keep it as a fraction. All right, so if you need some help breaking down roots, email me. I'll do some together with you, whatever you need. Okay, so not all of your answers will be imaginary if you do the quadratic. I just wanted to show 2 examples, especially for the reducing. Not all of your quadratics will reduce either. So try your problems and see what you come up with. All right, let me know if you need help.